So we're going to talk about why a certain element is in this group and what are the properties in this group. Okay, now, for your IGs, similar to your Form 4 that you're going to learn this year, okay, you only learn about Group 1, Group 8, 7, and transition metals here. Okay, hold on. Okay, so we're only going to talk about Group 1, Group 7, Group 1, Group 7, Group 8, and then transition metals. Okay, so but first of all, we talk about why are elements in Group 1. So for example, lithium, sodium, potassium, I'm sure you know by now, lithium is 2-1. Okay, because it has 3, right? So lithium, the electron arrangement is 2-1. Sodium, 2-8-1. So everybody in Group 1 have 1 valency electron. So 1 valency electron, this one tells us the group. Okay, so if you're in Group 2, you have 2 valency electrons. So for example, beryllium is 2-2, magnesium is 2-8-2, and so on. So Group 3, 3 valence electron, 4, 4 valence electron, 5, 5 valence electron, 6, 6, 7, 7, and 8. It has a full outer shell. That's why it's known as Group 0. Okay, it's known as Group 8 and also Group 0. Okay, all right. So that is for 7 and 8. Okay, transition metal have many different valence electrons, so we put them all in transition metal. They don't have a specific one. They have many different, a variety of valence electron. Okay, now what about periods? This is called period 1. 1, 2, 3, 4, and so on. Okay, so period 1 has only 1 shell. Hydrogen has 1. Helium is, the electron arrangement is 2, just 1 shell. Then lithium there, 2-1. So 2 shells. Beryllium, 2-2. 2 shells. Boron, 2-3. 3 shells, and so on. So this one very easy. We've talked about this last year also. Okay, so this part, any question? This part here about, okay, so periodic table is a method of classifying elements to use to predict its property. Why predict a property? Same group, same valence electron, same properties, same chemical properties. Okay, same group, same valence electron, same chemical properties. That means the way they react with water, the way they react with whatever is all the same. Then the trends in a group is like, for example, let's say they have all low melting point, but as they go lower, the melting point increases, but they're all lower melting points, for example. Okay, now metal and non-metal. Okay, so metal and non-metal. So what happens is everybody on the left-hand side, okay, everybody on the left-hand side are metals. Everybody on the right-hand side are non-metals. Okay, so we have a zigzag part in the periodic table. This part here, boron, silicon, germanium, arsenic, antimony, tellurium, hormone, astatine. Okay, so you don't really need to know everybody. You just need to know there's a zigzag line. Okay, there's a zigzag line. And those that are on the line or beneath the line are semi-metals. Okay, but the ones that you actually need to know is only silicon and germanium. They only ask you these two. Okay, actually, if you just remember silicon, very good already. So these are semi-metals. Semi-metals means they have both metallic and non-metallic properties, but everybody on this side are all metals, and everybody on this side are non-metals. Okay, now, do you guys all remember metal and non-metal properties? Hello? Guys, remember not? Metal and non-metal properties.
No.
Huh? Don't remember? Okay. So as long as it has 1, 2, or 3 valence electron, is usually a metal. It has 4, 5, 6, 7, or 8 valence electron is considered a non-metal. Okay. So metals, all metals are. Okay, please write this part down. What do all metals have? Okay. All metals are shiny. All metals can conduct electricity. All metals can conduct heat. Okay. All metals are shiny. All metals can conduct electricity. All metals can conduct heat. All metals are malleable. Do you remember what's malleable? Malleable is you hammer, you knock onto it, it can change shape. Okay. All metals are ductile. All metals are sonorous. Ductile means can be drawn into a wire. Sonorous means when you hit it, it has a clanging sound. Okay, however, you need to know about group 1 metals and you need to know about transition metals. Okay, all metals, that means group 1, group 2, group 3, transition metals, all metals can do this. But there is a difference between group 1 metals and transition metals. That means group 1 metals and transition metals can all do this, but they also have special features. Okay, can you please write this down first?
Yeah, Christina, what's ductile again?
What's the what?
Ductile.
Ductile means can be drawn into a wire. That means you can make it into a wire. Okay, are you guys done?
Yeah.
Okay. Ready? What's the last word? Sonorous. Let me write it down again. Sonorous means it's like a bell. When you hit it, it makes a clanging sound. Okay. All right. There's a lot of construction at my place. It's very annoying.
Is a nearby construction at my house and it's making my nose very sensitive.
Oh, that's horrible. If you're very sensitive to dust, it's already very bad.
Been living like this my whole life.
Poor thing. You can get something to help you know.
Yeah, I use a nose sprayer thingy.
Okay. Okay. Now, everyone ready? Okay. Who can remember what is another name for group 1 metals? Lithium, sodium, potassium, rubidium, and all that. What's another name for group 1 metals? Wait, nobody can remember.
Flammable metals. I don't know.
Alkali metals. Remember, group 1 metals are alkali metals. Okay, so okay, let's talk about group 1 metals. Okay, we talk about a normal metal, which is from transition metal, for example, iron, versus a group 1 metal, for example, sodium. Okay, now, if I take 2 cups of 2 beakers of water, okay, the first one, I put an iron nail. The second one, I put a piece of sodium. Okay, please tell me, what will I see for the iron nail?
Rust.
Hey, you're so funny leh. You put the iron nail in water, you see rust.
It, it was sink.
Yes, it will sink. Where got see rust so fast? Okay, you will see it sink. The iron nail will just sink, and then it will rust after a few days. It won't straight away rust. But the sodium will not sink. Okay, will the iron nail straight away react, or will it take a few days? Few days. Okay, it will take a few days. The sodium will react immediately. The sodium will start to, it will float, it will dissolve, and it will bubble. Okay, it will float, it will dissolve, and it will bubble. It's very vigorous. The reaction is very, very vigorous. Okay, so group 1 metals are more reactive. Transition metals are less reactive. And then it can float on water, right? So it has lower density. But all transition metals, all the other metals will sink. It has higher density. When I want to use a piece of sodium, I can take a knife and I can just cut it, because these are soft metals. Okay, the metals are like butter, like that. They have a feeling of butter. They're all soft. This one is hard. Okay, let's start with that. Okay, so group 1 metals are also known as alkali metals. The reason why they are known as alkali metals is they dissolve in water to form alkali. Okay, have you written all this down yet?
Yeah.
Huh? Okay. Okay, are you guys done copying?
Yeah.
Okay. Ready? Can I continue? Can I? Okay, so we're going to focus on group 1, lithium, sodium, potassium. So group 1 is lithium, sodium, potassium, rubidium, cesium, francium. Okay. So we talk about these three first, okay? So group 1, lithium, sodium, potassium. Of course, there's rubidium, francium, cesium, francium. That's not important lah, because no one is going to let you play with rubidium. Okay. So as you go down, it becomes more reactive. Okay, the size becomes bigger from 2,1, 281, 2881. Okay, 2,1, 281, 281. The size becomes bigger, it becomes more reactive. Okay. Now, what happens is, how does it react? All alkali metals dissolve in water to form an alkali and hydrogen gas. So for example, lithium plus water, you get lithium hydroxide, which is an alkali, and hydrogen gas. Okay, please write down this equation. Please write this down and write down the equation for sodium and potassium with water. Okay, are you guys done?
Yeah.
Yeah, done. Okay, so as you go down the group, it becomes more reactive. So lithium dissolves in water to form lithium hydroxide and hydrogen. Sodium dissolves in water to form sodium hydroxide and hydrogen. Balance the equation. And potassium dissolves in water to form potassium hydroxide and hydrogen. So all the same, 2, 2, 2. Okay, so what happens is, as I said just now, if you take lithium and put in water, lithium will go like that. It will fizz, it will release hydrogen gas, and then it will become alkali, and then it will start to dissolve. Okay, if you take sodium and put in water, it will fizz faster because more reactive. So it go fish. Okay, and if you put potassium in water, because it's even more reactive, it will fizz even faster. And because the reaction is so exothermic, it will release so much heat that it will burst out in flames. Okay, and all of the solutions that are produced are alkali. So if I had put phenolphthalein inside, if I put phenolphthalein or any other indicator, it will change to, for example, phenolphthalein changes to purple. Okay, so that is group 1. So when you go back to school physically, most of your labs have this, so your teacher might let you play with it, because this is a Form 4 chapter. It's very easy. Okay, now what if I put rubidium inside water? What do you think will happen?
Will it burst?
It will explode. Yeah. If you put rubidium inside water, it will explode. If you put cesium inside water, it will explode even faster. Later, I'll show you a video. Francium, no one is going to let you play with francium because it's a very rare element. There's only 1 gram of it in the whole of Earth's crust. Okay. So as you go down, it becomes more reactive. Okay, it becomes more reactive. As you go down, it also becomes more dense. All of them have very, the density is all very low. Okay, the density for all of them are very low, but the density increases slightly. Okay, it becomes softer. As you go down the group, it becomes softer. And then the melting point and boiling point decreases. Okay. All right. So please write this down, and then I'm going to show you a video about what happens when we put them in water. Okay, so group 7 in the periodic table, as you go down, it's getting bigger, but it gets less reactive. The size becomes bigger, it's higher melting point, and it gets darker. Okay, and they all exist as diatomic molecules. Okay, now there's a difference between the natural state. Okay, we're going to talk about this natural state. Fluorine, chlorine, bromine, iodine. Natural state meaning that when you find them by themselves, without adding water, without putting them in any solvent, nothing, just natural state. Fluorine is a pale yellow gas. Chlorine is a green gas. Bromine is a red or brown liquid. Depends how concentrated it is. And iodine is a black solid. Okay, so you see, as you go down, it changes from gas, liquid, solid. Can you see that? Okay, and then it changes from pale yellow to green to red brown and black, or orange brown, sorry, not red brown, orange brown to black. Okay. So is the color getting darker or lighter?
Darker.
Darker. So the color gets darker. The state changes from gas to liquid to solid. Okay, now we don't use them as chlorine gas, bromine liquid, iodine solid in the lab. We will all die. So we use them after we have dissolved in water. Dissolved in water, we don't use fluorine. Nobody uses fluorine. It's too reactive. Everybody in your lab will die. We don't use that. But we dissolve chlorine in water. We call it chlorine water. Although we call it chlorine water, the formula is still Cl2. Bromine is called bromine water. And iodine is called iodine solution when we dissolve them in water, okay? This one is pale yellow. It's a very light color. You can hardly see it. It's like swimming pool color. Bromine water is brown and iodine solution is also brown. Okay, Ken? So when we use it in the lab, we say iodine solution. We don't use black color iodine. But if the question is just asking you, what is the state of iodine? Please don't go and write liquid. No, it's a solid. Okay, the state of iodine at room temperature, for example. Okay.
Okay.
Okay, you guys all done? Understand?
I'm a bit confused
About what?
about the temperature thing.
What temperature? Sorry.
You said that room temperature about
Yeah, at room temperature. Okay, so for example, I ask you, what is the state of water at room temperature? What will you answer me?
liquid.
Liquid, correct. So if I ask you, what is the state of iodine at room temperature? You cannot say water because, oh, teacher, I saw iodine solution in the lab. No, that is iodine dissolved in water. The state of iodine at room temperature is a solid. Get it?
See.
Yeah. If I ask you, what is the state of normal table salt in room temperature?
Solid.
Solid. Yeah. You cannot tell me, teacher, in my house, I have salt water. So my state of salt in my house is liquid. You cannot say like that. It's still solid. Get it? Get it?
Yeah.
Okay. All right. So okay, everyone done with this? So today's one's very easy. Now only we're going to get into a little bit harder part. We're going to talk about equations. Okay, we're going to talk about equations. So
Teacher,
yeah,
when chlorine dissolved in water, it's too reactive.
it's true. Fluorine itself is a very reactive gas. So it doesn't really dissolve in water. We don't use it in the school lab
Oh, okay.
because it's a poisonous gas. Actually, all these are quite poisonous, but the rest are liquid one. But or solid. This one is gas. It's you put it in water, it doesn't stay in the water. Not that like in your toothpaste, right? In your toothpaste, it doesn't have fluorine. It has fluoride. They use the fluoride salt in your toothpaste. Okay, can you understand?
Okay.
Okay, so reactions. Okay. So like this, fluorine is 2,7. In order to achieve full outer shell, what does fluorine do? Gain electron or lose electron? What does it need to do?
Gain electron.
Gain electron.
The proton acceptor.
No, proton acceptor. No. Proton acceptor is different. Proton acceptor is hydrogen ion. This one gain electron. Proton acceptor is acid, that one different. Okay, so it will try and gain 1 electron to form 2,8. When it forms 2,8, now it's a full outer shell and it's a negative ion. So from fluorine, it becomes fluoride. Right? Correct. Now, fluorine, it becomes fluoride. Okay, now, if I give you a formula F2 and sodium fluoride, which one is it a fluorine molecule and which one is it a fluoride?
F2 is fluorine.
F2 is fluorine, correct?
The other
This
one's
one is fluoride. This one in sodium fluoride is already a F negative. So which one has already received electron?
Sodium chloride.
Sodium fluoride, yes. Okay. All right, now, so like this, okay? We pretend fluorine is playing basketball, okay? Electron is the ball. When it receives a ball, when it hasn't received the extra electron, it's a fluorine molecule. When it has received it, and it has an extra electron, now it's a fluoride ion, okay? So this one is fluorine molecule, haven't received electron. After it receives electron, it becomes a fluoride. Now, why is this important? Okay. So this is very important. You must know the difference between molecule. You must know the difference between molecule and ion. There's a very big difference. Okay. Right. Now, have you all copied this part here? Actually, no need to copy lah. You all know what I'm talking about, right? So this part here is where you need to listen. So fluorine is the dad in the family. Chlorine is the mom in the family. Bromine is the big brother in the family. And iodine is the shortest in the family. Okay? They are all playing basketball. The goal of basketball is to get the ball. Okay? Who is going to get the ball here? Fluorine, chlorine, bromine, or iodine?
Fluorine.
Fluorine, because fluorine is the tallest. So fluorine gets the ball. Fluorine changes to become fluoride. Okay? Fluorine gets the ball. Fluorine changes to become fluoride. Now, chlorine, bromine, iodine all really want the ball. Can they say, please give me? Cannot. They're not going to give you. Okay? So, too bad. Okay, so fluorine walks away. Fluoride walks away with the ball. Okay, now, left chlorine, bromine, iodine. Somehow, the ball rolls on the floor. Somehow, the ball rolls on the floor. And bromine got the ball. As soon as bromine gets the ball, bromine is no longer bromine. Bromine is now called a bromide. Get it? Bromine has now become a bromide ion. Okay, iodine says, please, 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 can I have the ball? Chlorine says, give me the ball. Who is bromide going to give it to? Chlorine or iodine?
Fluorine.
Chlorine. Okay, it must always give it to the taller person. It will have to give it to chlorine. Can it say no? Cannot. Okay, so chlorine says, give me the ball. Bromide says, okay. So chlorine takes the ball. Chlorine now becomes chloride. Now chlorine becomes chloride. And bromide now changes back to what? Bromine. Can you understand? This is called displacement. Somebody takes the electron away. It's called displacement. Okay? Now, somehow, iodine gets the ball. Iodine is now no longer iodine. It is called iodide. Okay? Bromine says, give me, give me, give me. Yes. Does iodide have to give? Yes or no?
Yes.
Yes. So iodide say, okay, take. Bromine gets the ball. Bromine becomes bromide. Okay. Iodide changes back to iodine. Poor iodine. Iodine always loses the ball. Okay, can you understand? This whole process is called displacement. Displacement. Okay, now, exam, they don't draw cartoon for you. Exam, they draw like this. Okay. Now, displacement. Displacement is like this. You take a test tube. They tell you inside the test tube. Okay. You have potassium iodide. Okay, you have potassium iodide. Then you add chlorine water. Now, the first thing I want you to do is, okay, the first thing I want you to do is write down the formula for chlorine water and write down the formula of potassium iodide. Okay, draw this and then write down the formulas. Okay, what's the formula for chlorine? What's the formula for chlorine? Anybody? Hello? Wait, guys. What's the formula for chlorine?
Ki.
No, that's potassium iodide. Yeah, potassium iodide is Ki. Chlorine, chlorine?
Cl.
Not Cl, but Cl?
Cl2.
Cl2. Okay, Cl2. Chlorine, bromine, iodine always must be in doubles. Chlorine, chlorine, bromine, iodine. Okay, this one is Ki, this one is Cl2. Okay, which one is an ion?
Chlorine water.
Which one is an ion?
Chlorine water.
No, chlorine is a molecule there. Chlorine is a molecule like this. Molecule, diatomic molecule. So which one is the ion? In a compound like sodium fluoride, fluoride is the ion. So now potassium iodide. Potassium is an ion, iodide is an ion. Get it? Can understand so far, guys? Okay. What is the color of potassium iodide?
Brown.
Iodine is brown. Potassium iodide. Think back, think back. Potassium iodide. All group 1 salts. What is the color?
Colorless.
Colorless. Yes, all group 1 salts are colorless. So potassium iodide. This is iodide, not iodine. Potassium iodide is a colorless solution. So this is a colorless solution. So I open my eyes and I look at this solution. It is colorless. Okay, I add chlorine to it. Okay, now, who is holding the ball? Iodide is holding the ball or chlorine is holding the ball? Who is holding the ball? Who is holding the electron?
Iodide.
Iodide. Can chlorine ask? Is chlorine stronger? Can chlorine ask for the ball? Yes, no?
Yes.
Yes. So chlorine says, I want the ball. Chlorine says, I want the ball. Chlorine becomes chloride. What kind of equation is this called? This is called a half equation. Okay. Iodide says, Okay. Take the electron. So iodide changes back to iodine. This is gain electron reduction. Do you remember? This is loss of electron. This is oxidation. Both of these are called half equation. Please write this down. Okay, are you ready? 10? All right, now you can combine these two together to form an ionic equation. Chlorine, iodide. It's like your math simultaneous equation. The two electrons in front and the two electrons at the back can cancel each other out. This one, the arrow is the same as equals to. So this plus this equals to this plus this. Chloride plus iodine. Okay, this is called an ionic equation. 6 plus 2 is 8. Okay, so overall, what is it that happens? You use chlorine first. You add chlorine to potassium iodide. It becomes chloride. So it becomes potassium chloride. And what's formed is iodine. This is called the chemical equation. Okay. Okay. What do you think is the color change? Potassium iodide is a colorless solution. Okay. When you add the chlorine, it changes from potassium iodide to iodine. So what is the color change? From colorless to what? What's the color of iodine solution? I just told you just now. What's the color of iodine solution?
Black.
What is the color of iodine solution?
Brown.
Brown. Okay. So what you see is colorless solution turns brown. Okay, so this is called displacement. Who displaces who? Chlorine displaces iodine or iodine displaces chlorine? Chlorine displaces iodine. Okay, everyone ready? Can you all understand? Hello, I want to give you a question. Can you understand or not? Okay, let's try one
Yes.
more. Can I? All right, let's try one more. Okay, like this. So here, I have sodium bromide. And I add chlorine water. Okay, please write down all the half equations and everything and then send it to me now. Half equations, ionic equation, chemical equation, and color change based on this. That means basically repeat this whole thing with this. Get it? Okay, please do it and send it to me now. Thank you. Okay, guys, I'm going to go washroom. Please do it and send it to me, yeah?
Yeah.
Okay, Jordan, I got yours. Okay, Jordan, very good. You just forgot to balance one of your half equations. The rest all okay. And can you just put there the color change?
Okay.
Okay. Okay, Gahe, correct?
Everything?
Yeah, you didn't give me the color change though.
Oh yeah, okay.
Okay, Maybelline, I got yours. Okay, Ihua, I got yours. Your chemical equation you didn't balance. Okay, Ziyu, I got yours. Ziyu, your second half equation is a bit wrong. And the iron equation, the rest okay. Matthew, are you done, Matthew? Matthew, are you there? Are you finished? Okay. Okay, we give Matthew a few 2 more minutes, then only we continue, okay? Ziyu, you check your equation again, okay? Ziyu, you check again. It's very similar to the one I just did. Okay? Uh, Matthew, okay, Matthew? Okay, I just received. Okay, good, except, okay, I think I know where you guys got it wrong. Like this, okay? So remember that, remember that chlorine water is Cl2, okay? And sodium bromide is NaBr. So the one that reacts is the bromide ion. Okay, can chlorine ask for electron? Yes. So chlorine takes the electron to become chloride. Okay, now for this reaction, right, is exactly terbalik. So it's not positive, it's just bromide, it's negative. So it's exactly the same, except it's the other way around. It's written this way. Bromide become bromine plus 2 electron. Can you see that? How this one is this direction, and then this one is actually the same equation, but the other direction. Can you all see that? Ziyu and Matthew, you understand how you got the second one wrong? Yeah? Okay.
Teacher Christina,
Yeah.
if
It-
it's sodium fluoride instead of sodium bromide, would
There'll
they
be
still
no, there'll be no reaction. I'll
uh
give you an example later. There will be no reaction. Okay, so this is the half equation. Now, this one you just add it together. Chlorine plus bromide. Chlorine plus bromide. Plus bromide. And then chloride plus bromine. Okay, so overall, okay, this one they rarely ask you lah. This one is from your electrolysis last time. What they usually ask you is the complete chemical equation. So it's chlorine plus sodium bromide becomes sodium chloride and bromine, like that. Okay. Okay. Now, the color change, this one is colorless, same as above. Turns brown. Okay. Okay, are you all ready? Can you all understand? Can you all understand for those who got it wrong? Okay. All right. Now, okay, let's continue from, okay, can I scroll down? Can I scroll down already? Yeah. Let's continue from Gahi's question. Gahi was asking, let's say here it's, let's say sodium chloride, and I add bromine water. Okay, will there be a reaction? Who is holding the electron? Who is holding the electron here? Chlorine or bromine?
chlorine?
Chlorine. Chlorine is already holding the electron, right? I'm already holding the electron. Bromine is taller or shorter? compared to chlorine? Bromine is taller or shorter?
Shorter.
Shorter. So can reaction, is there a reaction or not? This one got reaction? No reaction. Because bromine is less reactive than chlorine. Okay?
Yeah.
Yeah.
Can I? Okay. I don't want to teach so much in one day. Okay, so I'm just gonna do a quick recap of this chapter, this part, and then we're going to end the class. Okay. Hold on.